Welcome to Lesson 5. Here we'll cover matrix algebra functions in GNU Octave. Even the most complicated problems can be made simple if you know which functions to use. In the console, we can utilize a lot of functions that already exist in GNU Octave. To demonstrate these functions, we're going to first want a matrix A to work with. That matrix, as you can see here, is going to be of numbers 1 through 9, counting up through our rows. It'll be a 3x3 matrix that we can then input to these different types of functions. One example is the function determinant, where we type det with input A to calculate the determinant of our matrix. There is also a function for calculating our eigenvectors and our eigenvalues. This function can be typed out as EIG. You can see here we're declaring outputs of V for our eigenvector matrix and lambda for our eigenvalue matrix. V is going to be a 3x3 matrix with our eigenvectors down the columns, while lambda is going to be a 3x3 matrix with our eigenvalues down the diagonal. We can also calculate the inverse of a matrix by typing INV with an input of our matrix A. There's also a function to calculate p-norms. For that we type norm with our inputs of matrix A, comma, whatever norm we want. For this example, we put a 2 to calculate our 2 norm. We can calculate rank by typing rank with input of A, or trace by typing trace with an input of A. These functions are very useful and very quick to use as opposed to doing this work by hand. There are also ways that we can execute vector calculations in GNU Octave. For example, if we want to take the dot product of a vector A equal to 1, 2, 3 and a vector B equal to 4, 5, 6, all we need to do is type dot with an input of A, comma, B. As you can see here, we get 32. We can also perform factorizations and decompositions in GNU Octave. To perform an LU decomposition, we simply have to type the outputs of our matrix L and our matrix U equal to LU with an input of A. As you can see here, we get a result of our L matrix and our U matrix. The QR factorization process works in the same way. We type our outputs of Q, comma R, and we set them equal to QR with an input of A. As a result, we get our Q matrix and our R matrix. Try it out on your matrix.